Hello everyone. Today I will walk you through the Sarcasm Lens code base. It is a complete machine learning pipeline for detecting sarcasm in Hindi, English, code, mixed social media text. I'll explain how each script works from data process pre-processing to model training, covering 8 different models across 4 categories. So as you can see here I have divided into folders. So firstly we'll go to the scripts, then we go to the data pre-processing. First the step is the pre-processing step. So here you can see the splitting the camel case. As hashtags are commonly written into the camel case, it is splitted into this. Then next is a 7 step process for each of the text. First one is like lowering lowercase conversion. The second is removing all the mentions, the hashtags and everything. The third is like processing the URLs and removing them. The fourth one is like removing the punctuation. The fifth one is removing all the stop words of English language only. And seventh one is the removing the extra white space. So the next file is of combined data sets. So I've used a fire script here where you can specify a list of data sets you want to combine. So I've combined 4 data set I've used here, and I've used this script to combine all the data sets. So next we'll go to the traditional machine learning models. So firstly we'll go to the random forest model. So this loads and prepares the data sets. Then it splits into 0.2 test sets and 80% and 80% and 80% training. And also it is used stratify equal to y to maintain the class distribution. The next is the TF-IDF vectors. So max features equal to 5000. This limits the vocabulary. N-gram range 1, 2. This represents unigram plus bigram. Now this filters the rare terms like frequency less than 2 would be removed, and this would remove the common terms like 0.95 times or more. This would remove them. And stop words none, like keep stop words for sarcasm. So we are keeping it here. Then to the then this will fit transform it, and this is the random forest one. Max depth to till none, so the full tree length. N underscore estimator is equals to 100, so like 100 decision tree would be formed. The next one is the train SVM. So here you can see the SVM classifier. So this is C equals to C is the regularization parameter which we have kept to 1, and the max iteration is 1000. So 1000 times it will do this. And in the feature analysis, like it shows the top features by coefficient magnitude. So SVM uses the linear decision boundary. The next we have what we have done is like instead of the term like TF-IDF, we have used the fast text text embeddings. So first, like to prepare the data set, we have done this processing and everything. And the FastTech uses the skipgram algorithm. Here you can see the skipgram algorithm in the 100-dimensional embedding space, and it includes all the words as the min count is equals to 1. It includes all the terms, and skipgram predicts like context words from the target words. So the next is the get sentence embedding, like it splits text into words, gets a word vector for each word from fast text model, averages the word vector to get the sentence embedding, returns 0 vector if no words is found. Next is training random forest and train SVM, both for the cases of fast text model. Now we move on to deep learning models. So the first one is trained by LSTM model. So here we have used a tokenizer. So I'll show you the tokenizer code. So this fits the tokenizer, and it maps like words to integer ID based on frequency, and vocabulary size we have taken here is 20,000. Here you can see, and out of the words token are mapped to this token. Then there is also the sequence padding. So like it computes the max length from the text and like calculates the 95th percentile of the sequence length, and after that like it pads the shorter sequence with zeros. And so here is the model being used. Now we move on to the next transformer based approach. What I did is I've done it for three models: XLM Robert base, second one is BERT based multilingual quiz, and third one is IndicBERT by AI for Bharat. So here you can see the model names I have used. So you can pass the model name by an argument, and that this file would run for that model. So specifically for IndicBERT, there is Albert tokenizer, and for rest we have used the auto tokenizer. So like this creates Hugging Face dataset objects and like sets formats to the PyTorch tensor. So these are the training argument, like this is the learning rate, like number of epochs is 1. I've kept it for like quick training. Then the weight decay for the L2 regularization, and metric for best model I've used is F1. So I've used the Hugging Face trainer class, like it performs like automatic batching, gradient accumulation and evaluation. And thus I'll show you the readme file where it shows the performance of all the outputs. So here you can see the fastx plus random forest has the best accuracy, F1 score and precision. And like why it works, like because like fastx handles like code mix text effectively, and the character engram captures the transliteration variations. Also like the random forest captures the non-linear patterns, and it's a good balance of like performance and efficiency. So yeah, this is my pipeline. So complete pipeline is like pre-processing, uh, like it clean text handles code mixing normalize. The second one is feature extraction using TF-IDF sparse one, fast tag dense one, and tokenization of sequences. Third one is model training, and fourth one is the evaluation scores. So thank you.